Hello, welcome to the video series for best MCQs in ICSE Physics. We also welcome you to our YouTube channel Physics Theories and Numericals, where we intend to provide you best quality videos for easy and joyful understanding of physics theories and concepts for life. We have designed this MCQ series with lot of care. Here we are providing you MCQs with moderate level of difficulties. With each and every answers, we are providing you explanations so that you can refresh your concepts and strengthen them. With each and every MCQ, we are providing timers so that before we take you to the answer, you can reach to your option and check it. We have already uploaded the videos for your chapter 1, that is force, chapter 2, that is work, energy and power, and chapter 3, that is machine. This video is for your chapter 4, that is refraction. This refraction, we have divided it into 3 parts. The first one is refraction at plane surface. The second video that will be coming, that will be on prism, and the third one that will be on critical angle and total internal reflection. Here we start. From the ray diagram, identify which medium is rarer. Option A, medium A. Option B, medium B. Option C, none. Option D, information is insufficient. Your timer for 5 seconds starts now. Time's up. Let's see the answer. The answer is option B, that is medium B. You can see that in medium B, the ray has moved away from the normal. That is, medium B is rarer. Next MCQ. Again from the ray diagram of refraction, find out the angle of incidence and angle of refraction. Your timer for 10 seconds starts now. Time's up. Hope you have got your option. Let's see the answer. The answer is, for the first one, it is 62 degree. Angle of incidence is 62 degree and angle of refraction is 40 degree. You can see the angle of incidence or angle of refraction has always to be drawn with normal. So the angle with normal is for angle of incidence 62 degree and for angle of refraction it is 40 degree. Third question. Which medium is rarer? Again you have to find out from this ray diagram. Option A, medium P. Option B, medium Q. Again option C and D, none and insufficient information. Your time for 5 seconds starts now. Time's up. Hope you got your option. Let's see the answer. The answer is option B, that is medium Q. You can see that the ray has shifted away from normal in medium Q. How? In case there was no deviation, the straight line would have been same. The angle would have been 180 degree. But here angle is 186 degrees. That means in medium Q, the angle has shifted by 6 degrees. So medium Q is rarer. Next MCQ. For refraction of light, what can be minimum angle of deviation? And in that case, what can be the angle of incidence? Your timer for 10 seconds starts now. Time's up. Let's see the answer. The answer is option B, that is both are 0 degree. Angle of deviation, minimum angle of deviation is 0 degree, and in that case the angle of incidence is 0 degree. Let's understand it from the diagram. See, this is the case where the ray is entering on the surface at a perpendicular, that is along the normal. That means angle of incidence is 0 degree and angle of refraction also is 0 degree, angle of deviation also is 0 degree. Next MCQ. Again from the ray diagram, find out the refractive index of B with respect to medium A. You find out A mu B. Your timer for 15 seconds. You need to do a bit of a calculation here. Your timer for 15 seconds starts now. Time's up. Hope you got your answer. Let's see the answer. The answer is option C, that is 1.4. Have a look at the solution. You need to find out angle of incidence and angle of refraction. Angle of refraction has not been given directly, so angle of refraction you have to calculate, that will be 90 degree minus the given angle 60 degree, that is angle of refraction is 30 degree. So A mu B is sin I by sin R. Do the calculation, you find its root 2, that is 1.4 from the given options. Next MCQ. From the ray diagram, among the three refracted rays K, L, M, find out which one is the correct ray in case the upper medium is a denser medium. Which one is the possible refracted ray? Your timer for 5 seconds starts now, an easy one. Hope you got your answer. Let's see the answer. Answer is option A, that is ray K is the possible refracted ray. Because in denser medium the ray needs to shift towards normal. Next MCQ. From the ray diagram, find out the value of P mu Q, refractive index of Q with respect to medium P. You are given some angles. You have to calculate the refractive index of Q with reference to medium P. Your option for 15 seconds starts now. Time's up. Let's see the answer. The answer is option B, that is 1.2. Let's see the solution also. See, for refractive index you need to find out I and R, that is angle of incidence and angle of refraction. The angles are given. From there you find out I is 90 minus 30, that is 60 degree, I is 60 degree and R is 45 degree. So refractive index will be sin 60 degree by sin 45 degree. Do the calculation. It is root 3 by root 2, that is 1.2 from the given options. Next MCQ. A light ray enters from medium A to medium B as shown in the figure. The refractive index of medium B relative to A will be among the three options greater than unity or less than unity or equal to unity or 0. Your timer for 10 seconds starts now. Time's up. Let's see the answer. The answer is option A. It is greater than unity. Now see, medium B is denser. Medium B is denser, so the refractive index will be higher than 1. Next MCQ. A student has done an experiment to find out the refractive index. So he got the rays as shown in red. So a student traces the incident and refracted ray as below. He also draws a circle and gets the two lanes as shown. What is the value of A mu B? Three options. Your timer for 10 seconds starts now. Time's up. Let's see the answer. The answer is 1.25. Now, refractive index is sin I by sin R. If you assume the radius of the circle is R, in that case sin I is 5 by R and sin R is 4 by R. So you take the ratio, you get A mu B as 5 by 4, that is 1.25. Next one. When light ray travels from one medium to another, the direction of ray changes at the separating surface. The reason for this change is, there are four options: difference in temperature, difference in speed of light in two mediums, difference in relative density of the two mediums, difference in frequency of light in two mediums. You have to choose the correct option. Your timer for 10 seconds starts now. Time's up. Let's see the answer. The answer is difference in speed in two mediums. Now the option could have been little different also. In place of speed, you could have been given wavelength. So the change, the refraction, that is change in direction, happens for change in wavelength, that is change in speed. Hope you are liking this video. We would request you to like the video, share the video and comment. And also subscribe to the channel and press the bell icon. Next MCQ. The refractive index of water is 1.33. So the speed of light in water will be, three options given, small calculation, easy one. Your timer for 10 seconds starts now. Time's up. Hope you got your answer. Let's see the correct option. Correct option is option C. The calculation is, speed of light in vacuum is 3 into 10 to the power 8 meter per second. So speed of light in water will be 3 divided by the refractive index, that is 3 by 1.33, that is 2.26 into 10 to the power minus 8 meter per second. Next MCQ. For a given pair of medium, refractive index for red, violet, blue and green colors are represented as mu R, mu V, mu B and mu G respectively. Select the correct option. Which refractive index is more? You have got 15 seconds. The timer starts now. Time's up. Let's see the answer. The correct option is option B. That is, refractive index of violet color is maximum and red is minimum. The reason is, in vacuum the speed of all color of lights are same, but in other medium speed of red color is maximum, speed of violet color is minimum. So refractive index is the ratio of the two, speed in vacuum to speed in the medium. So refractive index of violet will be maximum, and for red it will be minimum. Next MCQ. Select the wrong one. Be careful, select the wrong one. A mu B. Which ratio is correct? You have got 15 seconds. Be careful. Look at it carefully. We will get your answer. 15 seconds time. Timer starts now. Time's up. Let's see the answer. Answer is option B. Frequency does not change. When light travels from one medium to another medium, frequency does not change. Next MCQ. There are two easy ones clubbed together in this: transparent material with maximum refractive index and the refractive index of that material. You have got 5 seconds. Quickly get to your option. Timer starts now. Time's up. Let's see the answer. The first one answer is option B, that is diamond. The second one, refractive index for diamond is 2.41. Next MCQ. Refractive index of diamond is 2.4. Just now we saw. What is the speed of light in diamond? 4 options. Again, a small calculation. 10 seconds timer starts now. Time's up. Answer is 1.24. That is option C. 3 divided by 2.41. That is option C. Next MCQ. Identify the incorrect statement. There are 4 options. Go through it carefully. Get to your option. You have got 15 seconds time. Timer starts now. Time's up. Hope you got your option. Let's see the answer. The answer is option C, because refractive index of rarer medium relative to denser medium cannot be higher than 1. It is lesser than 1. Let us look at the other statements also carefully. Option A. Refraction happens at the surface of medium separating the two mediums. That is correct statement. Option B, you may find it little confusing. Oblique ray may travel from one medium to another medium without refraction. It can happen if the refractive index of the two medium are same. Option C is the incorrect statement. And option D, for a given pair of medium, violet ray deviates the most during refraction. That's a correct statement. So the answer is option C. Next MCQ. You have been given refractive index of glass relative to air, that is X. Refractive index of water relative to air, that is Y. Then what is the refractive index of glass relative to water? You have got 4 options and 10 seconds time. Timer starts now. If you think you require time in between, do pause the video, take your time and come to your answer. Time's up. Let's see the answer. The answer is option A, that is X by Y. Now, refractive index of B relative to air is absolute refractive index of B divided by A. So it will be X by Y. Next MCQ. Light ray traveling through glass slab. Air, glass, air. Find out the correct ray diagram. Easy one, a very common kind of a question. You have got 5 seconds time. Get to your option in 5 seconds. Timer starts now. Time's up. Let's see the answer. The answer is option B. Because from air to glass, ray will shift towards normal. Again, from glass to air, it will shift away from normal. So option B is correct. Next MCQ. Here it is little different. And an air box, transparent air box kept under water. That means light is traveling from water to air, then again to water. Find out the correct ray diagram. Your time for 15 seconds starts now. Time's up. Let's see the answer. The answer is option B. The ray is entering from denser medium to rarer medium, that is air. So in air it will shift away from normal. Again, when it is coming back to denser medium, that is water, it will come towards normal. So option A is the correct answer. Next one. Light of frequency f, wavelength lambda and velocity v in air enters into glass slab of refractive index mu. Then how will these quantities, that is frequency, wavelength and velocity in glass, will change? What will be the new frequency, wavelength and velocity? 4 options, 10 seconds time to choose. Timer starts now. Time's up. Let's see the answer. The correct option is option D. Frequency does not change. Both velocity and wavelength, they get reduced. They get reduced by refractive index times. That means wavelength becomes lambda by mu, velocity becomes v by mu. Next MCQ. A tricky one, be careful. In an event of refraction with partial reflection also, all the rays are shown. Refracted ray is shown and the partial reflection, that reflected ray also is shown. It is happening from denser medium to rarer medium as shown below. Find out the refractive index of rarer medium relative to denser medium. You have got 20 seconds. Timer starts now. Time's up. Let's see the answer. The answer is option A, that is tan I. Let's understand the calculation also. Now see, refractive index is sin I by sin R. So here it will be sin I by sin R dash. Now it's pure geometry. See, R plus R dash plus 90 degree, that is 180 degree. Look at the diagram carefully. R plus 90 degree plus R dash, that is 180 degree. So that is giving us R plus R dash is 90 degree. So R dash is 90 degree minus R. Now what is R? R is I, because angle of reflection and angle of incidence. So R dash is 90 degree minus I. So refractive index of rarer relative to denser is sin I by sin R dash, that is sin I by sin 90 degree minus I. Now you remember that trigonometric table. Sin 90 degree minus I is basically cos I. Check the values. Sin 90 degree minus I is cos I. So it is sin I by cos I, that is tan I. Tan I is the refractive index. Next MCQ. A glass slab is kept on a table. The thickness of the slab appears to be 10 mm when viewed from air. If air mu glass is 1.5, then what is the actual thickness of the glass slab? 4 options given, 10 seconds time, timer starts now. Time's up. Let's see the answer. The answer is option D, that is 15 mm. An easy calculation, we know real thickness by apparent thickness is air mu glass, that is 1.5. So real thickness will be mu into apparent thickness, that is 1.5 into 10, that is 15 millimeter. Next MCQ, a nice one, be very careful. A transparent slab of 21 millimeter has a bubble inside it. The bubble appears, you are looking at the bubble from two sides of the slab. So bubble appears to be at depth of 10 mm from one side, say we call it face A, and it appears in 4 mm depth from the other side, that is a face B. First question, what is the refractive index of this transparent material? 4 options, 20 seconds time. Timer starts now. If you think you require more time, you can pause the video in between, get to your option, then have a look at the answer. Time's up. Let's see the answer. The answer is 1.5. Let's understand the calculation also. See, the situation is like this. This is a glass slab. You can see face A and face B. From face A, the apparent position of bubble is at 10 millimeter depth, and from face B, it is at 4 millimeter depth. Had the bubble been at the bottom, you could have got this apparent depth at one shot. But here you are looking at from two sides. So if you add these two sides, total apparent depth is 10 mm plus 4 mm, that is 14 mm. And actual thickness of the glass is 21 mm. So mu, that will be real depth by apparent depth, that is 21 by 14, that will be 1.5. On the same setup, second question, what is the actual position or depth of the bubble from face A? 4 options. Now 10 seconds time, because part of the calculation you have already done. 10 second time. Timer starts now. Time's up. Hope you got your option. Let's see the answer. The answer is 15 mm. Again, let's understand the calculation. See, actual depth is apparent depth multiplied by mu, that is 10 into 15, that is 10 into 1.5, that is 15 mm. Hope you like the video. Please like, share and comment on the video, subscribe to the channel and press bell icon. Thank you for watching. See you in the next video. Bye bye.